In this video, we're going to explore some ways to start to quantify risk. So the first thing we want to look at is something referred to as sensitivity analysis. This basically shows us how a change in a variable, in this case they mentioned sales, how does the unit sales sold, how does that affect net present value or internal rate of return? In an example, we say, well, what happens if the number of units we sell changes by plus or minus 30%? If that's what's going to happen, how does that affect the answers to our capital budgeting techniques? Now, we've used and talked about this type of analysis before. We just didn't refer to it as sensitivity analysis. We used this when we talked about capital budgeting, and we talked about the net present value profile. This represented the change in net present value when we changed the cost of financing. So it produced a graph. We'll look at some graphs here in a second. But in this case, we look at what's the happens if the base level of an asset changes. How does that affect net present value if the unit sales change or if salvage value changes? So let's see a picture and how we might get this. So R is the required return. That's our net present value profile, actually. But the unit sold, you can see that there is a positive relationship. Hopefully this makes sense. The more things you sell, the greater the cash flows, the greater the net present value. But what we find here is the salvage value is very flat, though. So what they're essentially, the picture, what I get from this picture is that the most sensitive variable here is the unit sold. If we're going to spend money to research and try to really lock in the variables, where do we spend all of our money? We should spend very little time investigating and thinking about the salvage value. Why? Because most likely it's a very small percentage of the original cost, and it's out in the future, right? So whatever the number is you pick, it's going to be reduced by the time value of money when we look at the overall net present value for the project. Now, so we always want to do what? We want to make sure we're basically looking for two things. Does the slope go in the right direction? It does here in these cases. But the other thing is we look at the slope itself, right? How steep is that slope? That represents for us a riskiness or an uncertainty with respect to that variable. So steeper lines, greater risk. Again, this unit sales line, as we mentioned, is much steeper, right? So that's where we have to put our emphasis for our accuracy in our data. So what are some weaknesses of this kind of analysis? Doesn't look at diversification, right? It doesn't say anything about the likelihood of changes. It just says these are the possible outcomes. What's the probability that any of them occur? It's not addressed in this technique. Why is it analysis? Why is it so useful? Well, it gives us an idea of standalone risk, right? It identifies dangerous variables, right? Gives us some idea of some break-even analysis, right? What is the break-even values of our variables that make net present value a no or no-go type of an answer? We have another type of analysis, though, that's called scenario analysis. And in scenario analysis, we're going to take one step further in this type of discussion, and we want to create a worst case, an average case, and a base case scenario, right? So let's look at, again, how this might work. So we have some possibilities of sales. 11.5, 10,000, or 8.5, right? That's what we think is our sales are going to be. Now, whereas this is different from sensitivity analysis is we're now going to apply some probabilities. What's the chance that we'll actually sell 11,500? What's the and have a price at $2.20? How does this affect net present value? So there's a 25% chance that if these two things happen, in a best case scenario, we'll make roughly $15,073 in net present value. If the worst case thing happens, we'd have a negative net present value. So how we use this is how we talked about standalone risk with individual assets and securities, right? You put in, you use, in this case, it's called the project risk analysis worksheet. It's in the capital budgeting section or capital budgeting workbook. But you put in probabilities and you put it the expected net present values, and of course then we get the statistics. So in this case, what? On average, you're probably going to get a net present value of $1,854 here, right? Standard deviation is 8,827, has a coefficient of variation of 4.76, etc. We can intensify this analysis, though. We can look at the confidence levels. We can calculate the probability that net present value would be less than zero. We can do all of those calculations statistically, a little bit beyond the way this course is built, but this gives us, again, an idea of some averages, right? On average, this is the way it's going to go. The problems with the scenario analysis is it has some limited outcomes. Now, we only did 3 in this example. You could do 5. Can you do 9? You can do as many as you want. Turns out that once you get probably beyond 5, the additional benefit of all that math is probably minimized once you get beyond a certain point. But again, you're using a computer, so the formulas are pretty straightforward with Excel. Essentially, it says that basically all of these inputs are perfectly correlated with each other. So that means all the bad things that happen all happen at the exact same time. All the good things, they all happen at the same time. Well, we know that that's not true, right? So this process focuses on standalone risk. However, in the end, we may have to excuse me, we may have to make some subtle adjustments because of some subjective information we know about the economy, maybe something that we know about going on inside the company. So again, thanks for watching the video. See you soon.